Hi, it's Robin. We might think of the Commodore 64 as a single monolithic platform. Most of these machines here are NTSC, but this one is PAL, so there's that divide. But over the run of the Commodore 64, there were many other differences, even if many of them are minor. The kernel, spelt KERNAL, which is the Commodore 64's operating system built into ROM, actually has several variations between different Commodore 64 models, and even some other related computers that you might not have seen before. So I brought out several different Commodore 64 models here to help illustrate the differences between these different kernel revisions. I've wanted to make a video about this subject for a long time, but I don't own some of the variants, and I don't really like using emulators on my channel. But just recently I got this EasyFlash 3 cartridge, and I realized that its kernel replacement feature is exactly what I needed to show all the variations I could find. And just note, today I won't be getting into third-party kernel replacements like Jiffy DOS. We'll talk about that another time. So the first one we'll look at is one of my silver label Commodore 64s. Unfortunately, this one isn't working, but I just wanted to point out a couple things about it. These silver labeled 64s were among the very first ever made way back in 1982. This one also has this cool silver 64 badge around the power light. Another cosmetic difference is that the word power runs vertically down the right side of the power connector. Later models said power horizontally. And these early ones also have a 5-pin DIN for the AV port. Later models have an 8-pin. You can look inside this one. These early ones have the ceramic RAM chips. You can see here the date codes, 28th week of 1982 on the 6510 processor. And these are the various ROM chips, and this is the one we're talking about today here. Made in the 36th week of 82, it's chip 901-227-01. This is the kernel ROM, and that -01 indicates that this is revision 1 of the ROM. Right beside is the basic ROM, which basically remained unchanged throughout the run of the C64. But I'm happy to say that my other silver label 64, I got it working again. They were both dead for a while. This one's basically the same, but it does have the power label here that's like the more modern C64s. So I don't know if they changed that or if this was a replacement. And this one also has a Made in Canada sticker that covers up the Made in the USA sticker. So I think some of these were actually made in Canada. Both of them came from this Sphere Computer Literacy Center in Burnaby, British Columbia. And all this needed to get going again was several shots of this 404B contact cleaner by MG Chemicals, which is basically the Canadian equivalent of Deoxit. Let's give it a try. Hopefully it still works. There we go. So we're mainly focusing on the differences between the kernel revisions here, but you will note that the picture quality is pretty bad on this, or at least you'll see when I hook up some of the later Commodore 64s that the picture is a lot better out of them. These early machines aren't sought after because they're awesome. Well, they're awesome historically and because they're more rare, but they really aren't as good. If you want a trouble-free Commodore 64, you probably want one of the newer 64Cs. I'll show one of those later. So one difference with the early Commodore 64 is that if you poke 1024, 81, for example, this is just going to put a circle up in the top left corner of the screen. Now you'll notice that it appeared in white. And I often try, actually I didn't even do it this time, if you hit Control-2, it changes the cursor to white, which is a higher contrast. So I've heard that originally the Commodore 64 was going to have a default character color of white, but the early C64s had such bad video quality that the white just didn't look nearly as sharp, and they deliberately chose the light blue with less contrast to sort of disguise that the picture quality was pretty poor. That's especially over the RF, the television output. Looks a bit better here, but you can still see it's not that sharp. And another bug on these early machines was if you move down to the bottom of the screen and then you just type, or even I'm just going to use the space bar here. So it wraps around twice, then press delete. And load is printed on the screen, syntax error run. So that's a bit of a bug, but it's worse than that. The keyboard totally locks up. Except, well, you can sort of do, you can try to change cases, but there's nothing you can type, and even stop restore does not work. So your computer is completely frozen up. So that's a bug in the line linking and scrolling routine built into the Commodore 64 editor. That gets fixed in a later revision. And finally, if you're not sure what version of kernel you have, you can just print peak location 65408. And I'm not sure why, but the kernel version 1 prints the number 170 in hex. That's AA, and that may have been used just as a fill byte when they are making the ROM. So it's just kind of like an unpopulated byte. Eventually, later kernel versions start having sensible numbers there. But anyway, if you peak 170, you have a kernel version 1. If you have a copy of Mapping the C64, you can find that here in the entry for FF80 or 65408. And I don't really have a way of demonstrating this, but one other major thing is that kernel version 1 doesn't have any awareness of PAL or NTSC, or the slightly different clock speeds that later Commodore 64s would run at. This one, the RS-232 timing tables appear to be timed as if this computer has exactly a 1 megahertz clock. But as far as I know, it's actually 1.02 and a bit megahertz. So I don't know if that's just somebody did the math and they didn't adjust. If there was a prototype C64 that ran at exactly 1 megahertz, or it'd be pretty cool if this actually did run at 1 megahertz. Anyway, I believe it runs at 1.02 like later NTSC Commodore 64s. Okay, so that's kernel version 1. Moving on to kernel version 2. Okay, here's the later Commodore 64. This has kernel version 2 in it, but here on the back it still has just a 5-pin AV port. And it still has the vertical power label, but does have the more modern rainbow badge and power sticker. I'm also going to hook a data set up to it, and I'll explain that in a moment. So we'll again peek 65408 to show the kernel version. That way text still doesn't look all that great, eh? And we get back 0. 0 indicates kernel version 2, strangely. Now, kernel version 2 is what my first Commodore 64 had. Actually, this is my original Commodore 64. It's broken, and I would like to get it working again sometime. I don't know what's happened to the keyboard. I did want to point out here that chip 901227 is -02. So there's the kernel version 2 on it. Also want to say that I bought this in March 1984, and if you see here, the date code on the ROM is from the 13th week of 1983. I basically bought this a full year after that kernel ROM had been manufactured. Some of the other date codes on here, for example, the PLA up here, was made in the 35th week of 83. Actually, the kernel ROM is the oldest chip on this whole board, so it makes me think that even though they knew this was kind of a buggy chip, they still had a big bin of them and they stuck it in my computer anyway. Thanks a lot, Commodore. But I should point out that mine does have the 8-pin AV port. So how about that? We shouldn't make assumptions that certain hardware revisions are directly tied to what kernel version you have, even from the factory. Commodore just threw whatever they had on hand. So back to this working kernel version 2. If we do that poke 1024,81 again, did you see that? Well, nothing happened. The top corner is blank. That should put that circle up in the top corner. But if we move the cursor up there, there's the circle. So what's the deal? When the screen is cleared on kernel version 2, instead of setting the character color to white, they set to the background color. So everything that's poked on the screen is invisible by default. This is terrible. So this plagued me when I had my original Commodore 64 in 1984. I'd be typing in programs from magazines like Ahoy, and those programmers might have either kernel version 1 or version 3, so the game would work okay for them. The magazine would publish it. I would sit there typing in that program. I'd spend hours, and then the game wouldn't even work. It was invisible. It was unreal. So really what had to be done was, in addition to poking to screen memory, you poke to color memory for that same character position. There, and now I've poked the color white into that top left corner, and now the circle's visible. So anyway, that really got me when I was a kid. And that bug down here at the bottom of the screen, press delete. There, that would really happen to me. I'd be in the middle of typing in a basic program, like making my own game or typing in a listing from a program. I'd trigger that bug down there at the bottom of the screen like you're seeing. I'd be froze up. And that'd be the worst, because you lost. If you hadn't saved recently, it was all lost. And I didn't know of any way around that. I didn't have like a freeze or a reset button back then, which could help get out of this. So again, stop, restore, nothing. You're dead. But I eventually figured out that if I had my data set hooked up, there. If you jam around the keys enough in here, you can get that load to appear on the screen. And it's still froze up. You can switch uppercase, lowercase. But if you have your data set hooked up, then you really can press play, searching, stop. Then you can hit stop, and you got control of your computer again. Yes. So that affects kernel version 1 and 2. Okay, that's it for kernel version 2. Here's another C64 breadbin. This one has kernel revision 3 in it. So if we peek 65408, so finally somebody caught on, hey, we should have a sensible numbering scheme, 170, 0, and 3. And this also has the fix for poke 1024,81. See that there is a light blue circle in the top left corner. That's because when the screen was cleared during boot, the cursor color was the default light blue. Now that I've changed the cursor color to white, if I clear the screen and then poke there again, now it's in white. So color memory is initialized to whatever the current cursor color is, not the background, which was a terrible choice, version 2, people. Okay, and that whole business down here has also been fixed. There we go. As far as I know, it's impossible to trigger that error anymore on a kernel version 3, which, having grown up with kernel version 2, I really appreciate that fix. And just one other thing I want to show you before we move on to more interesting machines. For x equals 0 to 3, and if we're just going to peek memory here, or print the results of some peeks. Just going to print 4 bytes from 65526 to 65529 in this loop. Next, and here we go. It prints out RRBY. Well, I showed this in a previous episode. These are some initials hidden in the kernel ROM. Robert Russell and Bob Jans, who were 2 of the main engineers who made the Commodore 64. Bob famously making the SID chip, but also contributing in many other ways. Now, I've shown that before, and these initials are in kernels versions 1, 2, 3, and in the SX64. Okay, I find it hard to believe I haven't shown this on my channel before, but this is my Commodore Executive Computer SX-64. And it's apparently the world's first portable or luggable color computer. Okay, hopefully it still works. Ooh. Yes. The built-in screen does work, but I'll do the video capture there. So this is almost completely Commodore 64 compatible, but it does have a different kernel revision, which you can see on the screen. The boot up message is different, SX64 Basic version 2, but it's essentially identical. And you can see it has a different color scheme. It is in fact the VIC-20 color scheme back again. So it has this higher contrast color scheme, probably to help improve the readability on the tiny built-in CRT. So if we print the kernel version number, it returns 67. Now it seems like a strange response, but I don't know if it's because it's actually kernel version 3 plus 64. I don't know. Maybe they thought it'd be cute. Besides these cosmetic changes, the other major thing, the SX64 does not have a cassette port, so they've removed the cassette routines. So if you type load on its own, you get an illegal device number error. And if you hit shift stop, which is this run, it automatically tries to load from the disk. You may know that on regular Commodore 64s, it automatically loads from tape when you hit that key combination, comma 81. And you see that that bug is fixed. It's printing in blue like kernel version 3. Oh, sorry about the blink. So for the rest of this episode, I'm going to just go back to my usual 64C, but I'm going to be plugging in the EasyFlash 3 cartridge. So up in the top left corner are many different kernel replacements that were shipped in, as far as I know, official Commodore release machines. And the kernel replacement feature of the EasyFlash 3 will allow us to try those on this otherwise stock Commodore 64, because unfortunately I don't own the remaining machines that I want to demonstrate today. So I'm going to choose option 5, which says 4064. Now the computer has booted up as this Commodore 4064 Basic version 2.0. Commodore actually released 3 strange machines called the Educator 64, the PET 64, and the Model 4064, which were essentially a Commodore 64 motherboard inside a PET case. These were aimed at the education market, but they did not catch on, and they're very rare. But you see here, it has a different boot message. It doesn't say anything about the amount of RAM free. It has white text on a black background. These machines actually didn't have a color monitor, so that must be why they chose this color scheme. You actually can still use Control to change the cursor color. So I'll change it to this cyan. Hello. So they haven't disabled the color feature, well, not completely. Watch this though. If I try to poke the border color, or the background color, to white, comma 1, did you see how it flashed on the screen and went right back to black? I'll do that a few times. So hopefully that's showing up there. So you can actually change the color through BASIC. You can poke memory, but the kernel has been modified so that about 60 times a second, the background colors are set back to black. I guess they did that to try to help. I can't really explain it. I'm sure it has to do with these non-color. I'm reluctant to call them monochrome because some of them displayed shades, a grayscale, I suppose, monitor. Anyway, that is very odd. And there's one other really strange change here. If we type in that same program again for x equals 0, 2, 3, print character string peak x plus 65526. Again, just displaying what's in ROM on the screen. Only RR shows up. And I looked in memory, it's zeros over BY, Bob Yang's initials. Somebody very deliberately zeroed out his initials but left Robert Russell's. Robert, did you do that? Were you angry when Bob quit Commodore and you were left to work on the Educator 64 by yourself? I don't know. I'd love to hear the story behind this. If there is some spat, I think both of you guys are still around. It's Christmas. Why don't you guys call each other up, eh? By the way, this is pure speculation. I don't really know what happened there, but it is weird. Now I'm going to choose number 7, Japanese. So again, we have the VIC-20 colors here, and the boot up message looks the same at first, but then you might notice, normally this number is 38911. So if we print 38911 minus the reported 863 bytes free, that's a difference of exactly 2 kilobytes. So where did that 2K go? People had speculated that this is because the actual Japanese Commodore 64 has an extra character set, and that's where that 2K is gone. But no, that's actually not the case. Okay, so I restarted with my SD drive plugged in. So I'll load Superman 64. Okay, so to look at this, we'll go into the monitor. And if we look at location 2B, it points to, it's a 16-bit address, 1001. This is the start of BASIC. On every other Commodore 64 computer, BASIC starts at 0801. But on the Japanese C64, it starts at 1001. Well, along with the VIC-20 colored boot up screen, probably for VIC-20 compatibility, moved the start of BASIC to 1001, and that reduced the total amount of memory by 2K. It's a bizarre choice they made, but so we can illustrate that. Normally when we go in, we go like print hello world or whatever. That's our program in memory. And then again, we'll pop into the monitor. And if we were to look at 0801, normally we would see hello world here in memory. Instead, this actually confused me when I was preparing for this episode. We're actually looking at code from the EasyFlash menu that's left behind when this kernel replacement mode kicks in. I'm a little surprised that RAM isn't cleared, but I guess that would take longer, and maybe it doesn't really matter. Just to confirm that, just this code here, this is definitely not C64 BASIC. This is not the program we typed in. If we look at memory at 1001 hex, there it is. These 2 bytes are the link to the next line. These 2 bytes are the line number 10. 99 hex is the token for the print command. This is a quotation mark, and then here we go. Hello, and you can see it over on the right here. Hello world. Store it at 1001. Very strange. And just to look at a couple more kernels, there's this Turkish one, which I think was official, but maybe this is a third-party one. I just found this online. I don't know much about it. It's got this weird boot up screen, strange color scheme of green on black with a blue border. And presumably the Turkish Commodore 64 would have a different character set in ROM. This would have some of the special characters that language uses. Like what's a C64T? Teletechnic or whatever. I guess it's a modified Commodore 64. And the Swedish C64 Now this one looks totally normal. Here is my actual Swedish Commodore 64. Thank you, MV. And it has the extra keys as stickers on here. But what's different is the keyboard mapping. If you use the 64 a lot, you'll notice that here, normally a colon is down here, but instead it's got this O with the umlauts over top. Yeah, I'm so good at other languages. That's the difference. But I think it'll be easier to demonstrate this, even though I have the real one. Here on my 64C, if I press colon, I instead get the English pound sign. The EasyFlash can't remap character ROMs, or we would see those extra dots on the screen. And here, if I press plus, I get minus instead. If I press minus, I get the equals sign. If I press the pound key, I get a colon, and so on. It's all mixed up. That is how the kernel would be modified for a localized keyboard. So just demonstrating that that's what the change is. And if I reset, it's also number 2, the Danish. I think this is the same thing with different keyboard mappings. Those all seem normal. Oh yeah, there. So I'm pressing the semicolon key and getting the pound. And I press equals and I get the semicolon and so on. So some of these kernel revisions are essentially just alternate keyboard mappings, and I don't think there's anything else to them. Okay, and the last one we'll look at is number 6, the C64 GS kernel. Okay, the C64 GS is a Commodore 64 without a keyboard. And somehow they thought this was a good idea. I think this was the Commodore UK. They released a Commodore 64 to compete with the NES, but they didn't do it till about 1990. They took away the keyboard, and then they ended up selling it for about the same price as a C64 with a working keyboard. Didn't have any other advantages, but had plenty of disadvantages. So anyway, it did really poorly. But the reason I'm bringing it up now, unfortunately I don't have one, I'd like to have one just because, is it has this bizarre little animation that somebody made for them around 1990 that shows that it is wrong to plug in a cartridge when the power is on. So instead you should turn the power off, plug in the cartridge, then plug it on. So it's just this little warning. And it is based on kernel version 3. I checked it with a hex editor. I've heard that there's actually some windowing routines built into this as well that nobody ever used, and I don't know enough about how to trigger them to show them now, but that might be something interesting for the future. So that's it. Did I miss anything? I think I got all of them, but I might have missed something. I also may have made some errors. I tried to do a lot of fact checking on this, but an episode that was just going to be full of information like this, it's likely I made a mistake. Check the comments. I'll put a pinned note if I did make any serious mistakes. I'll list them there so you guys can get the real facts. Okay, if you're looking for further reading, I'll also put some links below. There's a great list of differences between the different kernel versions by Marko Mäkelä, and there's a link to that below. All right, thanks to my patrons for their support of my work here. If you're interested in supporting what I'm doing with the channel, then check out that link, and there's some perks to those who support me. If you haven't already subscribed, please do. Thanks for watching, and we'll talk to you next time.